Hello, again, welcome. I'm sure that my sound is audible. If it is not audible, be comment on the comment section so as to what we have to try to modify for the next. Now we are on the second the practical session of this pharmaceutical analysis one. So the second experiment is mainly focused on the assay of aspirin. Do you know assay is what? Estimation of the active ingredient of your any pharmaceutical product. So this aspirin, you know that it can be obtained from the willow tree from natural product concept. Be sure this aspirin is also synthesized in laboratory by using acetic anhydride react with salicylic acid in the presence of sulfuric acid as a catalyst. So the one that can be produced by this mechanism, this drug can be used for anti-pain drug, which can be given either alone or in combination therapy. Therefore, this drug have its own active ingredient which can be estimated by this experiment. It is this active ingredient that have pharmacological effects, or the therapeutic category is mainly focused on this active ingredient. So now, as same is estimation of the active ingredient. So in this experiment, you want to determine the percentage of purity of the given sample of aspirin. What is required for this experiment is the commercial aspirin that can be given for the patient nowadays. So you have to bring your aspirin sample rather than from the commercial market rather than the aspirin we have to prepare in the laboratory. So you know that this aspirin can be react with sodium hydroxide so as to produce sodium salt of aspirin plus sodium hydroxide excess plus water plus sodium acetate salts. Here, since sodium hydroxide is excess, the titration here is back titration. You know that back titration is mainly used for if some reactant is excess in the given stoichiometry of the reaction. Therefore, here we have to use back titration to determine the amount of aspirin or the percentage of purity of aspirin. So from this reaction, you have to see that a simple nucleophilic reaction can be takes place. Have a look at the acetic acid function. Here, the carbonyl carbon of acetic acid is highly electrophile due to the two oxygen can be withdraw electrons through inductive effect. Now, sodium hydroxide having OH minus acts as a nucleophile, donating an electron for this electrophile. Therefore, the reaction that takes place between sodium hydroxide and the aspirin is exactly a SN2 reaction because it is one-step reaction and it is nucleophile reaction. So from this reaction, you have to see that the amount of sodium hydroxide which is excess. So when you come to the procedure, this experiment have actually two sections. The first one is standardization of 0.5 sodium hydroxide. Then you have to the second or section 2 is the real experiment of assay of aspirin. So to standardize sodium hydroxide, actually you have to done this experiment in experiment 1 of these courses. But to standardize 0.5 normal of sodium hydroxide, what required is that the burette, which can be filled with 0.5 molarity of HCl, which is primary standard. Conical flask having 25 ml of sodium hydroxide, indicator which is phenolphthalein, and the change or the color change can be seen from pink to colorless. Do you remember in experiment 1, during standardization of sodium hydroxide versus oxalic acid, the end point can be observed by this pink color. Now, this pink color can be disappear for standardization of sodium hydroxide against HCl or hydrochloric acid. So here the calculation can be, as I mentioned before, N1 V1 N2 V2, where N1 is normality of HCl, which is actually equivalent with molarity of HCl because the number of hydrogen lost here is equivalent to 1. If N is equal to, if Z is equal to 1, always normality is equal to molarity. The same is true for sodium hydroxide. Here sodium hydroxide release 1 OH during dissociation, Therefore, the acidity of sodium hydroxide here is 1. Therefore, by this principle, you have to determine the exact molarity of sodium hydroxide by this calculation. And finally, the exact molarity of sodium hydroxide also equivalent with theoretical molarity of sodium hydroxide, which is 0.5. Once you have to know this, you have to proceed for actual experiment, which is sample reading or assay of aspirin. What is required here is the burette, which can be filled with which is filled with 0.5 molar of HCl, and the conical flask having a sample or a drug or aspirin, 0.5 gram of an aspirin plus 25 ml of sodium hydroxide solution. Here the indicator we have to use is what? Phenol red, and the color change can be happen from red to orange. When you see the color change from red to orange, you have to stop the titration and record the volume of HCl consumed yes, from the burette, that thing. So this one is observation. Actually, the pink color can be slightly changed to the red color can be changed to orange, but it seems pink. So, but you have to know that the color change here is from red to orange. So when you come to the actual experiment, which is sample reading, here maybe you have to get maybe 0.5 40.8 ml of burette reading. So the difference between the titration represents the amount of sodium hydroxide required for aspirin is given like 25, which is we have to the volume of sodium hydroxide. First we have to take for the dissolving of the aspirin, that means minus the amount of HCl consumed at the end point, that means when the color change from red to orange. So the change is actually 10.2 ml. So once you have to calculate the purity of aspirin. So you know that the molecular formula of aspirin is C8H8O4 with molecular weight of what? 180 gram. In the stoichiometry of the reaction, if you remember, 2 mole of sodium hydroxide can be reacted with 1 mole of aspirin, which means that 1 mole of sodium hydroxide is excess here. So 100 ml on 1 liter of 1 molarity of sodium hydroxide means that 90 gram of aspirin. So this one is how you have to find the factors of calculation here. So in 1 liter or 1 molarity of sodium hydroxide can be required 90. You have to decrease by half because 1 to 1 mole relationship or 1 to 1 mole ratio must be equivalent. So 1 to 1 become 90. So now if you decrease the molarity of sodium hydroxide by 0.5, the concentration of aspirin can be decreased again by half, that is 45 gram. So 1 ml of 0.5 molarity of sodium hydroxide equivalent with 0.045 gram of an aspirin. Therefore, in 10.2 ml of burette reading of 0.5 molar of sodium hydroxide is equivalent with 0.05 gram of an aspirin times equivalent burette reading volume, that is 10.2 ml actually. So the amount of aspirin in a given sample becomes 0.459 gram. Therefore, by using this formula, this amount of sample used, you have to determine the percentage purity as follows. So the percentage of purity of an aspirin equivalent with the amount of aspirin over the weight of the sample times 100. This means that 0.459 over 0.5 times 100, which equivalent with 91.8%. The result, percentage of purity of an aspirin is 91.8. Now, having this result, and go for the pharmacopoeia and check whether the impurity or the purity range of an aspirin is between this or not. If it is far below this, and you have to check, your result actually must be what? In the range of that pharmacopoeia or monograph for the aspirin. For different drug, there is a monograph that used for what? Keeping all things about the drug, starting from description to that of different how to use and the bioavailability as well as the pharmacokinetic profile of the drug. Therefore, you have to check there and identify whether your experiment is error prone or error free. So we'll cover other practical skills to get an interesting video like this, don't forget to subscribe the channel, press on the bell icon on the channel, and you have to get a notification while I upload a new video for you. So thank you very much for watching, and as I mentioned before, don't forget to subscribe the channel and comment on the channel, comment section of the channel, so as to improve the place where some defects or defaults are there. So at the next video, thank you very much, and have a fun on the channels.